As you see, this is circuit diagram as shown here, and starting we will have four main things. We'll have, first of all, okay, we'll have tuna vitu vinne kwenye circuit yetu. Kuna power supply, sawa. Cha pili tuna power supply. Cha pili tuna control circuit. Cha tatu tuna input. Cha nne tuna output. So we have four main category or blocks in this project. We have power supply, we have control circuit, we have input, and we have output. I will start one by one. So starting from here at the bottom, you can see this is power supply. This is power supply. Power supply consists with AC input from Tanesco. Then here it's a transformer which step down the voltage from 240 to 12V, but it will remain DC because it's not filtered. So after here we'll put bridge rectifier. This bridge rectifier negate all the negative voltage which comes from this one. So if I'll give you an example from this, we can say before putting any bridge rectification, it will be like this. It will be like this. This is sinusoidal. This is sinusoidal signal coming from Tanesco, which here is 230. Sorry, my hand lighting is bad. And here it's sinusoidal waves. So after inserting the bridge, after inserting the transformer, this will slow down these waves from 250 to 12, but it will remain AC. It will remain AC, but the peak voltage will be 12 here. Here will be 12. So after here before transformer, here after transformer, then we apply bridge rectification. I think you know about bridge. So if we apply bridge, this voltage will come. I will negate all these negative waves. So will remain only in positive. Will negate and will inverse. Will inverse up these negative waves. So will remain with all positive. So after this we will apply some filters. You can see here we applied 1000 microfarad filter. You can check the voltage rate by applying twice the voltage rate of this transformer to avoid bursting of this, because the maximum voltage is the maximum capacitor it can carry. So if you apply twice the voltage, it will have a wide range to deal with. So capacitor we got 1000 microfarad, 25 voltage. These other capacitors supports these regulators. So we have two regulators. I will explain later. So after capacitor here, what will remain? It will be like this. The voltage will go up, but when it try to slow down, it will be negated by capacitor, because capacitor will have charge at that time. So these are stages to rectify voltages in our project. But after that, we'll have to look uh, to this two regulators, which are 78. You see this 78 12, and these are 7805. These two numbers at the end represent voltages. So 12 is a 12 voltage, 05 is a 5 voltage. So this is give out 12 voltage, and this give out 5 voltage. So here are capacitors to deal with these regulators, to filter the noises, and here is LED, light emitting diode. This for indication purpose, to see if the electricity is coming out from these two regulators. For example, this deals with these regulators. I didn't put LED to these regulators because I see it's nonsense, and it's just an option. So even this is option. So this is voltmeter. Okay, so this is power supply. We have 12 volt and we have 5 volt. Why 12 volt and 5 volt? 12 volt, it goes and feeding these motors and motor drivers and pumps and everything. But 5 volt, it goes and feeding microcontroller, LCD display, and some little components like these transistors and so on. So okay, this is power supply. So I've already talked to you about power supply. So here we come to control circuit. In our control circuit, we are using Atmega 328P. This Atmega 328P. If you go and dig to the data sheet of this Atmega, it has 28 pins. You go and dig deep to that microcontroller. It has 28 pins, which in each side we have 14 pins. So among these 28 pins, more than, I think it's 7 pins are used as general purpose pin. I can write here. A microcontroller, it has 28 pins, and 20 pins are input output pins, and those 7 to 8, I think 7 to 8 are general purpose pins. So don't care about this misspelling. So general purpose pins. So this general purpose pins include 2 VCC, ground, a reset, which is 1, and crystal oscillator, which are 2 pins, and I think it's all about this. So so maybe these are 21 pins. So you can check to the data sheet. I think I don't need to explain more about that. Data sheet explain more than what I will explain. So you can see 21 are input output pins. Among those 21 input output pins, among all 21 input output pins, there are 6 analog pins. There are 6 analog pins, which are from A0 up to A5. So these are analog pins. From here we can find the analog here. These are analog pins. From this one, you can say A0 or PC0. So all are just nicknames, or ADC0. Analog. So these are analog pins. So after here, analog pins can be used in detection. For example, if you want to use temperature sensors and other analog giving values, inputs. But digital pins are used to detect digital or to give out digital. So analog can give also analog outputs. Okay, so this is control system. So let's come to the input system. Input system in our project, I just inserted the button. This button will be used to allow the execution of our the beginning of execution of our project. You can see here this little button is attached. This button is attached to pin number 4. This is pin number 4. So if I press this button, I will initiate the process, and this is only our input. And when we come to output, we have motors. These motors, we have pump. This is our output. We have relays and some other stuffs. And here, motors, bear in your mind, we cannot control motor, we cannot drive motor direct from microcontroller, because microcontroller gives out a little voltages. These voltages cannot drive motor which is 12 voltage. Microcontroller give out approximately 5 to less than 5 voltage, but most of motors need more than 5 voltages. Even if it will need sometimes 5 voltage, but the current will be higher, it will require higher current than we expect. So we cannot use direct these motors to microcontroller. So we need drivers. This is motor driver, which is called L293D. So there are a lot of them. There are L2998D, L293D, and etc. So these motors have capability to drive more than one motor. This motor driver has capability to drive more than one motor. So most of this L293D has capability to drive 2 motors at the same time. So here at the input, we'll put the input of motor 1 to certain pins, and you can see here it's in one, and out one. So this correlate to this, and here you can see these little pins, which is in 3 and in 4, which gives out 3 and out 4. So the same as this one, in 1, in 2, in 3, in 4, out 1, out 2, out 3, out 4. So this gives out. So when you insert any signal here, for example, you insert high here, if this pin comes out high, and then this will be excited to 12V according to this reference I've put. You can see this reference. You see? So if you excite this, it will give out 12V according to this voltage reference you put. So we have this voltage, which is 12 voltage here, goes to this VSS and VS, which are input power. So if you excite at any voltage, for example high, it will give out 12 voltage. So this 12 voltage will go and excite this motor. So it will depend. If you give here it's high and another in 2 is low, it means here it will be high and here it will be low. So motor will go to this direction. If you exchange polarity, motor will move to another direction. This is the advantage of this motor driver, can use to control motors in either directions. So this is just arrangement of motors and pumps. So I've used this also to drive heater, because heater which I used here is 12V heater, and I don't know about the implementation. I can use more than 12. So I'll change this driver according to the specific needs. So the pump the same, we use 12V, but when it comes to this little valve, we have two transistors here which comes here and drive this relay, and relay will drive this relay the valve here. So I just put relay to represent the valve, but after here it will be valve. So it's LED to indicate that that valve is on or off, and it's LED to indicate that valve is on or off. So among all things I've explained, there is another another output to explain, which is this little LCD. I think you know this is LCD, which is 16 by 2. It means it has 16 characters. You can write 16 characters to here and 2 characters from here to here. So if maybe you write A, B, C, D up to 16 character, and here you can write only A to B. So this has these little pins which are D0 up to D7, which are used to input signals from this microcontroller, and this reset register and enabler are used to enable and insert the register. Register is like a memory. So if we put some words here into this microcontroller, and this reset register can reset the memory, and enable can enable which character to display at the same time. So here we use D1 up to D4, which means we are using only 4 pins. We are using only 4 pins to display character in this display. It means the D1 up to D4 are coming from this D1 up to D4. This is the same if I take out this and connect direct to this. Take out this and connect direct to this. So it's the same. So we used only 4 pins because we have discovered that we can use 4 pins to display any character we want. Early, before this discovery, we used to use all these 8 pins, which were called 8-bit configuration. So for now we are using 4-bit configuration, because we know that these 4 little pins can be used to drive any voltage we want, or any signal we want to display any character here. So it's advantage to us because microcontroller got few pins. So if we utilize few pins to display, it will be advantages to other components that will be required to be inserted or as an output. As you can see here in our microcontroller, we only have 3 pins remain. So if we would have to use all these pins, it would be hard and difficult for us to display any character here, because we would have 1 pin remain from connection. So for example here 1, 2, 3. So we would take 1, 2, 3, but 1 pin would remain. But for this discovery of 4 pins uses is 4-bit configurations. It comes to advantages that we can use few pins to display this, but in our implementation we will use 2 pins configuration, which is called I2C. I will explain it later when it comes to implementation. Last but not least, here is our little crystal oscillator, which comes to these pins. So what the aim of crystal oscillator? Crystal oscillator used to produce frequency so that microcontroller can execute codes. And this is the configuration of crystal oscillator. We will have 22 picofarad and crystal at the middle. Then this extol 1 and extol 2 will go direct to these points. So this is the same, like I will take the wire here to here, I will take the wire here to here. So this is our circuit, and here it shows the first plate, and here it shows the second plate. As you know, this circuit is used to cook this, what they call vitumbua in Swahili. automatic without any control. So this container 1 may contain maybe this container 1 may contain maybe the paste from rice paste, and this container 2 will contain the paste from rice paste. So each container will deal with each bucket, or with each bucket to receive those rice bars. So I'll give you an example. I'll come here and simulate so that you can see. If you simulate, you see hello screen here welcoming you to this circuit with smile. Then it will load a little bit to allow the circuit to settle, the code to settle. So after loading, it will say place, start, or stop. This is our button, which is for start and stop. So if I place this button, you'll see machine will go online. Then it will open this. It will open this front panel. After opening this top panel, then it will pump the oil. To these pans, to pump the oil for certain time. Then it will hit our pan for certain time. This is procedure 2. Then it will come to another procedure. It will come to another procedure. It will open these pastes, rice pastes. It will open, and then it will insert to this pan for a certain time. So we'll have a configuration later on, or calibration to see. Then it will start cooking. So the heater will remain on for a certain time to allow these buns to cook for certain times. It will be on for a certain time to allow. You can see here in display. Then after cooking for a certain time, I will see a little delay because cooking allows we want to allow, or to make sure the buns are cooked well at required time. Okay, then it will close a top panel. So remember, it was open, so now it's closing the top panel to allow to flip. So after closing the top panel, what will follow? It will flip this panel. After closing, you can see it will flip this, rotating the pans. So it will rotate these pans upside down. So this will go up, this will go down. At this moment, the heater is off, the pump is off, and the paste is not filling. So after rotating the pans, it will open these low pans. But remember, these low pans, it will be up at that time. So it will open. It means this paste goes or exchanged to another, because we flipped it. So it will go to another. It's like we are cooking chips with eggs together. So it will start cooking, because we don't want to cook while these all two pans are closed, because this is not procedure. It will be different when you cook. When all these pans, we will feel the taste will be different. So it will start heating for a certain time. So heating for a certain time, it will goes on, because it will require some little time, which will calibrate later at the end. Then it will rotate that pans down to drop. It will drop those buns. It will rotate to drop those buns down. You can see here it's a bucket to receive those buns. So it will rotate. Then it will rotate to start the same procedure. So you can see here procedures are going, and you can see, as I explained before, this 7805 gives out 5 voltage. So the procedure will go on and will repeat again and again. So this is our project. I think you understand. If you got any question, please don't hesitate to contact me. Thank you.